The HVAC School podcast is made possible by these great sponsors.
White Rogers and Copeland and their universal furnace control to replace up to 550 different part numbers. The White Rogers 50M56X-843. I've talked about it a lot, and I know that's a lot of letters and numbers, but it's the 50M56X-843 does it all. No extra harnesses required. Just plug in, detect, and go. White Rogers, smarter HVAC solutions. Learn more at hvacrschool.com/connect controls.
The ESCO Institute and the HVACR Learning Network. Our friends Howard and Jerry Weiss, Jason Objute, Eugene Silberstein, Clifton Beck, all great guys who are huge advocates for the industry, are working hard to provide industry-leading online content for HVACR professionals. Visit hvacr.elearn.network to access reliable, up-to-date, and relevant digital resources and even earn continuing education hours. Enhance your knowledge today with HVACR Learning Network from the ESCO Institute. As always, find out more by going to escogroup.org.
Carrier and Carrier.com. Carrier has been a long-term sponsor of the podcast. They've made it possible very early on for us to do what we do, and they are the products that we sell day in and day out. Everything from single-stage equipment all the way up to the Green Speed Extreme, one of the most efficient products on the market today. Find out more about what Carrier has to offer and about becoming a Carrier dealer by going to Carrier.com.
Refrigeration technologies, and specifically Viper wipes, the all-purpose wipe that is really amazing what it can cut through. Everything from mastic to oil, grease, tar, grime, and it's nice on the hands. Makes them nice and soft when you're done. So that way you can go home and head out a-dancing when you get back to the house. Find out more at refrigetech.com/viper-wipes. refrigetech.com/viper-wipes.
And now, the man who tries to explain makeup, air, and ventilation to his kids whenever they eat out. Bryan Orr.
Happy birthday to you. This is the HVAC School podcast, and whether it's your birthday or not, you've hit the jackpot when it comes to HVAC knowledge. I need to stop improvising these. It doesn't go well. But anyway, this is the podcast that helps you remember some things you might have forgotten along the way, as well as helps you remember some things you forgot to know in the first place. And admittedly, just like the last episode, Bert and I are a little punchy when we record this, so I apologize in advance for any silly, ridiculous humor. It just tends to happen when we get together. And today we're talking about water leaks, condensation, water damage, water that shows up places that we don't want it, and how to prevent it, and how to develop your Spidey Sense around it. Because it is very expensive. It's very costly to have water ending up where it don't belong. And it's one of those areas that, again, becoming masters of the obvious, being situationally aware and noticing things, being a good noticer is really, really helpful to prevent those issues. So here we go. Bert and I talking about water, Spidey senses. Hello again.
Hello.
So with this Spidey Sense episode, we're going to talk about water.
Okay.
Good old H2O. Dose H, uno O. There's a lot of cases where water's an issue. And they're like the really traditional ones that backed up drain. But theoretically, and this is what I want to talk about first, I think a lot of times water leaks happen and we just like, well, that just happens. So water damage, issues on platforms, issues on ceilings, issues, whatever. And that's just part of it. These things happen, but really they shouldn't be. We shouldn't have water issues.
It is frustrating because it's one of the most easily preventable as far as it's very straightforward. The water goes downhill. You provided a path that's sealed.
And it shouldn't be going other places.
It should not be going other places.
So let's talk big picture because we're going to talk through some of these. But what are some of the most common causes of water being where it ain't supposed to be?
A drain backs up.
Drain backs up. And that's the only reason.
I wanted to say that first.
Always a backed up drain. No, not always. But that is obviously one of the most common. But a drain backup should not cause water damage.
Right.
Why?
Drain backup should be caught because of a float switch that shuts off our unit when the drain backs up.
And one of the things that, this is again a Spidey Sense thing. And so when you go to a unit, there's like this thing happening right now, and it's going to be really hard for me to not tell names, and I'm not going to.
Okay, good.
I'm not going to. But there was.
I just want you to know I didn't train that person.
No.
So this is a person who I had a feud with early in my, I think a lot of people are going to relate to the story. So I had a feud with this guy back in early stages of my career because he was like a big shot sales guy for this big company that I happen to work for that I won't name. And he was just like good looking, cocky. Everybody was his friend. And because I was the trainer and I was also a senior tech, he would just send me out on these jobs where the sales team totally screwed it up, where they just didn't do what they're supposed to do. And I had to figure it out. And he would always get snotty with me about it, about the situation or how I handled something with a client or what I said. And of course, I was a punk kid, so I probably was doing everything wrong, whatever. But in this narrative, I'm the hero because I'm the one telling it, of course. So now I get a call from, Phil Barr.
Mm-hmm.
Okay, so Phil Barr's wife, Jen, great lady, good friends of ours. And she helps manage a property. And this property is for one of her family members. And they keep having water leaks. And it's like this company just installed 3 brand new systems, multi-floor, super nice, on the beach, really pretty house. They just installed 3 systems 6 months ago, and they've had 3 major water leaks that have resulted in damage, significant damage, growth, the whole thing. This company is run by this guy. So he left the other one and started this whole thing. And so it's like immediately I get excited. Kind of just, I'm being that bad guy who's like, blah, blah, blah. Well, anyway, so it's this story, like they're not going to cover it. They come up with all these, well, the float switch was faulty.
Mm-hmm.
So it's actually the float switch manufacturer, and that's not part of the manufacturer warranty. It's basically a little loophole.
Drain is a maintenance issue.
Right. Yeah. They literally said that to her. 6 months ago, they installed the unit, and they literally said that, this is a maintenance issue. Isn't the float switch supposed to catch it? Yeah, but it was a factory fault on the float switch. Okay. So first off, that doesn't happen. Do float switches fail sometimes? Fail to work? Yes, they do fail to work. But is that like a common thing?
No.
No, it is not. And if it is, there's usually like a reason. There's something, maybe there's a faulty run of switches or like you're running too much current through it. Something's going on that's not normal. But the other thing that drives me crazy just as an industry is why don't we pay attention to, oh, hey, this air handler or evaporator coil or furnace, whatever, or dehumidifier is sitting over top of multiple floors. And if this thing leaks, it's going to do all kinds of damage.
Yeah.
So why don't we put a little bit more redundant thought? I'm talking to me too. We don't do a great job of this either, but just like redundant thought into, if this happens, what can we do to prevent it? How can we create redundant float protection so that way it doesn't happen again, at least? And in this case, it's been multiple times and now they got to replace. And literally, the story isn't over yet. They literally won't. They're trying to charge them to just even replace the platform tops and replace the boxes because they, of course, they're okay with it going to legal now at this point. They're just like, they don't want to own it.
Wow.
And it's just so insane to me.
Yeah.
It's like, I just can't imagine I'm having that. But this happens so often with water leaks because, of course, where there's water, things grow and then everybody gets afraid and then the lawyers get involved and whatever. And so if it's such a serious problem, why don't we take it more seriously in the first place? We know where the water's going to end up. So why don't we think about that?
And I think a lot of it is because it's often the easiest part of our job in that it's a very simple task to hook up the drain and to clean out it and watch it drain outside and feel great about what you just did. It's such a simple task that you don't stop and be like, it's not a technical task, I guess I'm saying. But yeah, it's very frustrating. I agree.
So first things first, from a Spidey Sense standpoint, is like when you go to a job where there is water, where there shouldn't be, I think we just need to say, okay, how do we make sure this never happens again? Or at least give the client options that will prevent this from ever happening again. Not, oh, well, that's just part of life. Because water dumping places it shouldn't be dumping is pretty costly and potentially has health impacts and everything else. So structural impacts, all that. You should take it more seriously when it does happen. And so drain backups can cause it. But then the second question should be, okay, but then why didn't a float switch
Why didn't the safety prevent the flood?
Correct.
Exactly.
Float switch, wet switch, pan switch, whatever it is, maybe all of the above.
Where's our secondary pan? What's going on here?
That's a big Spidey Sense thing. What do you run into, though, a lot where it's more than just a drain? And maybe it is that it wasn't cleaned adequately, but like maybe it starts that way, or it's like we cleaned a drain, but then it keeps going.
Yep. So one thing that you can run into is that you're reusing maybe a drain setup. And so during the process of installation, you broke loose a joint that's under a platform or a joint that goes around a corner, or it's an attic application. And in moving everything around, a 90, 10 feet away came loose. It was poorly glued back in the day. And so that's one area where it's not the drain backing up, but even after a maintenance, maybe you just came and you did a maintenance. And if someone does a maintenance and there's a big water leak and we have a working float switch, it's not our drain backing up. We got to find this elsewhere. So poor connections, is a really common one on the drain lines.
Yeah, one of the practices that is not perfect, but is helpful at least, is we have an apartment complex job we're doing right now, and I keep reminding them, make sure you do this, is the actual standing water test. Like you actually put what you cap it wherever it's going, whether it's going to a common drain or it's going outside. You cap it at the end and you fill it up and you make sure that water level's not dropping on you. You can't stomach even, for example, a lot of times somebody will press fit something, they'll dry fit it, and then they'll forget to re-glue that one connection. That's huge. That's that Spidey sense, because it's like, what was done here recently? Whenever something was changed, somebody replaced something, somebody put a new evap in, that's when it's likely for things to break that weren't previously broken. Or a maintenance. You know that tech, hey, this tech likes to blow out drains. They like to use the CO2 cartridge, or they like to use nitrogen. Much more likely that you're going to blow apart a drain when you use that sort of thing.
Or my AC seems to drip water in the house every time it rains. What else could be happening here?
Exactly. But even with the drain backing up, okay, so let's say you have a drain that's consistently backing up and you know it is backing up. Thinking about the reasons why that could be happening. One big one in our market is a lot of times under the house, they'll go to poly, this semi-flexible drain tubing that they ran underneath, and it'll have a kink in it. And that kink may have been there forever, or that kink may have been caused when we pulled on the drain or pushed on it or whatever. But a lot of times what happens is it's just much more prone to block when it has that. And that's where, and not only do installers need to have Spidey sense, like, yeah, we didn't know it was going to be this and now it is. And so now we should probably rerun this drain. This is going to be a problem. Let's prevent it. But service tech saying like, hey, we've been out here a bunch of times and it's not like a bacterial zooglea elephant snot thing. It's like, we're not really getting much out of this drain. There's not a lot coming out. And so what else is potentially causing it? So that's big. And again, at that point, because of the condensate switches, you shouldn't be having water damage,
right?
But at least it's a similar related problem.
And it's the same thing with a double trap in our drain. You shouldn't be having water damage with a double trap, but it's another common one that can go unnoticed and get missed and then show back up.
Same thing's true of drains that are improperly pitched, like through an attic or across a distance. I feel like I talked about this in the podcast recently, but I remember a case where I was there for a service doing a maintenance something, and then it became apparent that it was an issue with the pitch of the drain, so much so that now it was actually double trap. It didn't start off being that way, but you got a little buildup in there, and now you had a double trap, and the boss of the company was like, how on earth, after 8 years, has this become a problem when it was never a problem before? And it's not a invalid thing to think, because that's the Spidey sense thought. But recognizing that, yeah, but it's an attic application, and this drain is running horizontal for a significant distance. And so it's more likely in those cases that you would get that sort of a problem. It's more likely for sediment to build up in that horizontal portion, and or for the cable guy walked across the attic and broke one of the straps that was supporting the drain, or whatever the case may be. Because usually, and this is probably true everywhere, but definitely in our market, anything that's in an attic or in a crawl space or anything like that, it's not like we do commercial grade strapping quality. It's not like we're putting strut in place and using proper hangers or something to make sure that you're getting the pitch that you're supposed to have. It's a lot of times pretty sloppily done.
Yeah.
When you talk about double traps, though, like what are some of the Spidey sense things that you deploy that help you decide whether you potentially have a double trap?
One issue would be, and you show up and you got water in your float switch, and then you only pull out clean water from your drain, or you don't have water backed all the way up to the T currently. That's a sign that I didn't actually have a blockage that caused this. I have something else going on. And there is the frustrating thing about a double trap is that it will not always be consistent. It can be intermittent, and you just finally catch that bubble just in the right spot, and then it doesn't drain. And so can I run water through this? And does it come out dirty? Would be one indication. If it's not messy, then we got something else going on here. The other thing would be watching this unit drain. When this thing's running and it's draining, a double trap, an active double trap will often, before it blocks all the way, it'll spit the drain out, intermittent draining. It'll just drain for a few seconds, then stop for a few seconds, and drain for a few seconds, stop for a few seconds.
Mm-hmm.
And so then you know, okay, I got an issue here. I got to figure out. I got to solve, because even if this thing keeps draining while I'm here, eventually this is going to stop.
Another thing that can cause drain issues is, we talked about this recently, but improper trap depth. And this is more in cases where, again, in our market, we have these, the way we do it, run underground. And so there's this gigantic trap, and that's not normal. But if you have cases where your static pressure is high,
you can actually pull back air back into the trap. And you know that this is a problem because if you do a maintenance, for example, suck a drain line out and then don't refill with water, a lot of times they won't drain because the negative pressure is going to pull back through. And so whether you have a vent or you don't, if you have a vent, then you'll actually have air pulling in the vent, which you should not have. That's an indication of a problem. Matt Bruner and I had a funny conversation about this recently. The other, if you don't have a vent, then you'll get air pulling in the end of the drain when you have improper trap depth. And so that's another thing to pay attention to. Make sure your trap is deep enough. In most cases, having something like a 2-inch deep trap is fine if your static pressure is under control on the return side. But when you know you're going to have high return static, maybe you have some Mac Daddy filter in place, or you just know it's a reality, then that trap's going to have to be deeper.
Right. And pay attention when you hear gurgling, when you hear that drain. It's trying to pull in air against the water. Again, it might be draining a little bit, but you're hearing the gurgling, you know eventually this is going to be a bad problem.
For sure. All right, let's talk about ignition modules. You know, the good old ignition module. They fail sometimes. Sometimes we need to replace them, but it's a real pain in the butt to get factory parts sometimes. It just is. And when it comes to ignition modules, versatility is key. So, Wright Rogers Universal Hot Surface Ignition Module replaces over 325 part numbers, and it works with 24 volt, 120 volt, and 240 volt igniters. Why, that's all three. It's perfect for pool heaters, water heaters, furnaces, unit heaters, all kinds of different heaters that do the heating and need ignition modules. And the harness is easy to transfer. Just label, match, and plug in. Less time on installation means more time with the client and for the next job. Trust White Rogers for ignition solutions across all your systems. Learn more at hvacrschool.com/connectcontrols. hvacrschool.com/connectcontrols. And just remember White Rogers, that's the one you want to buy. Talk about the weirder condensation. We weren't talking about freezing at the end, but some of the weirder condensation issues, or where you get puddles of water on platforms, or you get stains in ceilings, or some of this other ductless systems, you get water leaking around down the bottom corner.
Those are the most frustrating. They are often the repeat callbacks. They're the ones that get blamed on other stuff. I clean the drain and everything's draining fine now. And then a little bit later, you get that same call. There's another drip. It might just literally be that I walked out into my lanai where the ductless is and there's another drip on the ground. And yeah, it's one drip. Man, that's hard to find. So chasing those, Spidey Sense wise, first of all, water goes downhill. We're at the lowest point. That's not our leak point. Let's chase that back and find how high up are things damp? Are things around this area wet? And try to find out where this leak is coming from. So an example would be like panels on the front of an AC. Let's say we have a garage application and there's water, standing water on the platform underneath. And it's more than just the maybe sweaty on a real humid day that you'll get here in our market. The outside of the unit might sweat a little bit as it reaches dew point. It's standing water down on the platform. You take those panels off and you'll notice there's water on the bottom of the cracks of the connection points of panels caused by insulation. But if you just keep running your hand and chasing that up, you'll find where's the highest point. And maybe there's an air gap here between the top panel and the lower panel seam or something like that. Mm-hmm. That is what I would say. One of the biggest things to actually solving it is to chase that water. If it's draining down the inside of the panel because the copper tubing is pushing against the panel, you'll see the water lines coming down from something higher. If you just show up and you're like, oh, it's been gathering condensation on these seams here on this air handler, let me throw some tape on it. You tape that all up and it's because the lines are pressing into the panel on the inside and water's draining down. It'll just keep leaking down, coming out your filter access door, soaking your filter. So chase it back, find out what the source is.
Again, this isn't a condensation episode. That's a whole nother thing. And I just recently did one of those. So I'm not going to talk about like vents. But to your point, like one of the things that a lot of guys get pretty confused is they're like, well, it's condensating on the inside. That's happening because it's too cold in the cabinet or something like that. It's like, that's not really how that works. The only time you're going to get condensation on the inside is other than in the designed location, which is the coldest point, which is the evaporator coil. It's not like anything around there is going to be colder than the evaporator coil. That would be real weird. So it's either that air is bypassing around the coil. So it's able to pass around the coil and rather than going through it, which happens at times because of panel fit and other things. Or it's coming in from the outside of the cabinet. We call those straws. So around different connection points for the electrical or the copper or whatever. Yeah. And so those are two things you want to look for. But in addition to that, like you said, anytime you have something that is condensating, like the tubes of the evaporator coil or the end
the U-bends in the end or whatever, if that's touching something and now the water doesn't run straight down and go into the drain pan, instead it drips off or runs down the panel or something like that, then that can be the cause. And you especially see this where guys will do this. It's a horizontal air handler in an attic and the insulation is totally saturated on the bottom panel. And they'll say, well, I see that a lot. It's just because of airflow. It's like low airflow caused it, or it's too cold or whatever. It's like things just don't just condense like that.
The inside of your air handler is not going to be soaking wet.
If it is, and it's not just going to dry out by itself just because of magic. It's not. Obviously, if you leave it off for an extended period of time or leave it just in the fan on position for an extended period of time and you can afford to do that, yeah, eventually it would dry out. But you've just saturated all the insulation now too. And so now it's not that it's going to continue to sweat in the inside, but now you've got compromised insulation that's going to sweat like crazy on the outside. Now
maybe you find your problem and you fix it,
Yeah.
but now you have a whole nother problem. You have an uninsulated panel.
And so using your Spidey senses and saying, okay, how is air making it around this coil? How is it coming in from the outside? Or potentially, how is there another water-driven problem? So water flying off the evaporator coil, making it into the panels. Maybe the thing was freezing intermittently and that was causing it. Maybe it's a side horizontal application. And this is a big one. You recently installed a piece of equipment, or the equipment's less than a year old, and now you've got these issues. If it's horizontal, pay attention to all of those details from the manufacturer. What changes in configuration did you need to make? And it's one of the first things that I'm going to look at if you have any water in the ductwork or water in the inside cabinet of anything that's horizontal in an attic.
Are we horizontal right? Are we horizontal left? What does the manufacturer say about? Because you often have to take parts of that coil, set up apart in the drain pan and configuration, change it, put it back together.
Yeah.
And if that wasn't done, you're going to be chasing a ghost trying to find that water.
None of us want to do that.
No, there have been times that I've put my camera with the light on inside the air handler and closed it up, turned it on just to prove water splashing off the end of that coil and jumping in the blower. We had a high static scenario that comes to mind where it was just whipping around different points on the coil because of the high static and missing the pan. So
when you get higher static, especially high static that's related to the coil, but it can be multiple reasons, you will get that higher velocity air that makes it around that coil, and it's more likely that you're going to have those issues. And that's where controlling static pressure is a big factor, but also making sure that everything is installed according to the manufacturer's information. Like downflow is even worse. I would never install a downflow system unless I had some wet switch or something down below that that's going to shut the system off, because it's just so likely. Now you got air pushing down. So any water that falls off is going to want to make it down into that duct below the unit. So just always thinking about, and again, there's different critical situations. You got a system in a crawl space where if it leaks, it's just going to drip on the dirt. It's like, okay, not as big of a deal as a system that's in an attic and 3 floors of Ming vase collections or whatever.
yeah, in both cases, you should do it right. But in the attic, you should stop, reset, and come back and say, did I actually do this right?
And did I put some redundancy in place
Yeah.
so that if you do have one float switch that fails or something silly
Yeah,
happens,
that's good.
that it's still going to shut the equipment off, which is that next thing that I want to talk about, which is freeze ups, because freeze ups are a cause of water leaks that feel harder to prevent. So talk about that.
They feel harder to prevent because you don't often see them happening and know what happened. And you get your periodic freeze up that the customer shuts off the unit or something shuts it off and it melts into the flow switch and backs up, and you show up and you're like, well, my drain backed up, but I got water in a bunch of weird places. One really clear indication would be you have inside panels soaked or you have your return box wet on the inside. And if your drain backed up and tripped the float switch, there shouldn't be water in the bottom of your return box. As far as finding it, that you look for things like that.
In addition to that, when you do know that it was a freeze up, the first thing to pay attention to is airflow, like we've talked about. And that would be, in a lot of cases, it's just maintenance related issues like a dirty filter. But when you have indications of freezing, and usually it is more like water just went everywhere. It wasn't discerning in where it went. Obviously, we talked about charge. You're going to check that, but airflow is the first place to look, and the maintenance related sides of airflow, evaporator coil cleanliness, blower wheel cleanliness, even things like duct sizing, static pressure, all that. Pay attention to those obvious things. But a lot of people will say, and this is one that I want to kind of address here, this Spidey Sense thing. They'll say, like, the reason why is the client set it too low. That's another one that a lot of contractors, I was waiting for that one to come up with my friend's situation. They're like, well, you just set it too low. Talk about that a little bit.
So the water damage that's related to that,
Why does setting a unit too low make it freeze?
Setting a unit too low and making it freeze. Well, first of all, if it is freezing, it typically means your unit is out of balance. Like you have some airflow issues. You do actually have the unit, a dirty filter in the mix, something like that going on. Poorly designed ductwork. If your unit is freezing, that's often typically why. However, you can, in our market, set that thermostat so low that as you bring down the indoor temperature, you bring down the coil saturation. And so eventually you hit that point where your coil is typically around 30, 35 degrees below indoor temperature. And so if you're down at 68 degrees indoor temperature, you're already in the freezing range for your coil by design. And in Florida, you have enough heat and enough moisture that thing's going to run long enough that it could freeze.
And it is kind of a perfect storm. So it's not just if you have a system that you set it low, let's say something crazy, let's say 65 degrees. So there's a lot of techs who will go out and say, and this is, again, the Spidey Sense. A lot of techs will go back, oh, they said it 65, that's why it froze. Spidey Sense says, hold on a second. Because just because someone set it to 65, that doesn't make it freeze.
That's right.
In fact, there's a good chance that they set it to 65 because it was frozen and they were trying to make it cool better in the house, and they were worried, so they just start mashing the thermostat down. That's a very common behavior, and we see that a lot in like vacation homes. And
so it's not that it can't happen, but you're right. It takes a combination. It takes a perfect storm. And so you should never assume that the ice buildup was as simple as the thermostat got set too low.
To be clear, it can happen, but it happens when you have long runtime, enough moisture in the air. So the system has to run a lot. It has to have enough moisture in the air, and it has to have actually gotten down to that temperature. So if you have a system that's freezing when it's set at 70, that's not it. I mean, a lot of people say, if you set this system below 74, it freezes. Okay, that means you have an airflow problem. That's what it means.
And that's how this gets started, right? Is that people prove this right or prove this to themselves because as soon as it got set lower, it froze. You just didn't address the airflow issue.
Correct. And so obviously, if you're keeping it at 78, then it probably isn't going to freeze, even with an airflow problem in most cases, unless it's real extreme. But having said that, can you freeze a system? Yes, you could take a perfectly running system, set it to 65 degrees, let it run all the time until it actually got the house to 65 degrees, and then it would likely be frozen at that point in our market. Because runtime, enough moisture in the air, and now at that point, that suction saturation, that evap temperature is low enough that it will freeze. That's the confusion. In summary, you don't freeze a system by how low you set it. You freeze a system by how cold it actually gets, how cold that return air actually gets going over that evaporator coil.
I want to take a second and talk about my friends over at the ESCO Institute and their excellent learning network, hvacr.elearn.network. That's hvacr.elearn.network. The e-learning network has tons and tons of training on there. Some of it even for me, believe it or don't. But they've got video training, they've got simulations, all powered by the ESCO Institute. To find out more, go to escoinstitute.org or hvacr.elearn.network. Especially for businesses, take a look at their bundled training content. Again, ESCO Institute at escoinstitute.org.
Next thing is like when there is a secondary pan in place.
Okay.
And you still had water go where it shouldn't go. Talk about that a little bit.
Boy, that's frustrating.
It sure is.
Sure is frustrating.
I go like this. I go,
well,
and the client's usually like this.
The most simple one comes to mind. We did install a system, and 2 years later, there was water everywhere. And we never actually put a cap on and sealed the auxiliary port on the pan. So that can happen.
If you're going to use a secondary pan without a drain attached, then you do need to cap that port or put a float switch in that port.
Which is pretty common in our market. There's a lot of setups like that where the safety is a float switch instead of an auxiliary drain attached. But another thing that is not too unusual is that you install this system and you support the drain pan that is empty and dry. And you poorly support it maybe on the ends of this long pan. And then when it fills up with 30 gallons of water and there's nothing supporting that pan on the center, it actually just collapses and dumps water everywhere. So that's another secondary pan mistake.
Another thing is I strongly recommend if you've got a secondary pan, use that secondary pan as like a fail-safe in case you have freezing or some of these other weirder problems. Don't use it to catch tons and tons and tons of water.
Right.
Put a float in the actual equipment too. So to put one in the secondary port of the equipment and put a pan switch or some other switch in the actual pan and try to get it at the point that the water's going to go to. Again, you want it to be flat, but think about that. Where's the water going to gather? Because there actually are pitched pans nowadays too.
And I'm fine if you give it a slight pitch and you put your float switch in the lowest point.
Yeah, as long as you're not also... the problem is when you slight pitch your drain pan, you're probably also pitching your air handler, and then I'm not happy about that.
Right. So yeah, it depends on your setup. But where you can, like almost always, you're going to have some sort of a low point. You'll see that. I have seen that many times where the float switch was just installed at the most convenient, quick place that a technician could touch, and water's draining out of the back corner behind the air handler because they didn't notice that it was pitched. It was low on the back side of the pan. But you could turn a pan that can hold 30 gallons into a pan that can only hold 2 gallons with just a slight pitch and put your float switch on that side. But another common mistake where water doesn't land in the pan is because your air handler is installed and then the plenum connection points coming straight off of the air handler are actually slanted down. And so that if the inside of your air handler is filling up with water, it's now draining down into your ductwork and moving outside of the range of the pan and looking for that next seam that's not watertight. So maybe you did a great job with your fab mastic tape with your plenum right on that air handler, but now you're flooding the whole ductwork. And so I always suggest to our installers that when you put in an air handler in the attic, let's connect the ductwork to it with just a slight pitch downward towards that air handler. So if this thing ever fills up with water, if it has a freeze, you have a blow motor fail, you have a giant block of ice on your evaporator coil, all that water is going to drain down into the secondary pan, not into the ductwork.
And that's where you also install a weep straw into the duct. So that way it just leaks water right.
That is a cool idea. Nothing could go wrong with a weep straw.
I just made that up. Don't do that. I was kidding.
Just drill a couple holes in the bottom of the area.
But this is common sense stuff. I mean, this is stuff that anyone who's paying attention would notice. And that's why it's Spidey Sense. You don't have to have special tools to do this. You're just like, hey, this could be a problem if this pan fills with water, what's going to happen? Is it going to collapse on me? Is it going to leak out of that port that I have completely uncapped? The other thing is make sure your drain pans are big enough. Like it should not just be the size of the unit. It should extend over the ductwork and capture any of that. I really do like the idea of pitching it back a little bit towards the equipment if possible. Is another big one. And you have a lot of vertical equipment that has pans under it as well. And I would say the same general approach. Still put a float switch in your secondary port. Just use that as a fail-safe. You got a freeze up, you got whatever, and it's capturing it underneath. It's a good best practice.
Be careful how you tie that float switch in.
If you have more than one, you mean?
Parallel. Always do parallel.
Right. Parallel.
See how that works for you.
Yeah. That way they both have to open in order for it to shut.
You need a flood everywhere.
Yes. You have to series or daisy chain is the term that a lot of people will use. Go into one, out to the other. You do not connect them to each other side to side. You connect them. I don't know how to explain this on a podcast.
It's hard on
many
a podcast.
times. It really is. It's like.
But look at your float switches.
In, out.
Can power make it through if one of them trips and the other one doesn't?
Then that's a problem.
That's a problem.
You want it to shut off everything. It's like any safety circuit.
Yeah.
Any one safety opens, it shuts off everything.
Yep.
That is a best practice. And that's also nice, even for things like freeze ups or whatever. You want it shutting the equipment off. And you don't want it to just keep running because you want a tech to know so somebody goes out and actually addresses it. You don't want this thing leaking water intermittently in and out over 6 months and have a gigantic fungus festival in your ductwork.
Yeah, mold.
We don't say
mold.
that. We say
Mold.
we say moisture or we say fungus.
I don't know why you're so afraid of the truth.
I'm afraid of lawyers. If you've driven through Florida and you see all the billboards, you know.
That's true.
There's going to be billboards next. It's going to be like, have you been listening to Bryan Orr's podcast? Call this number.
Did he say mold?
And I'll be like, no, that was Bert. And then they'll all come after you.
Wow.
Because I said fungus.
Bring it on.
Fine. I will.
I did want to cover the odd, just came to mind, but install issues where you have ran copper over your equipment or through an attic and the copper's poorly insulated or maybe it got torn in the process. There's a call that comes to mind where we went out several times for this ductless system, which was a cassette. It sits in the ceiling. And then the copper comes up above it and runs through the attic to go outside. And what ended up happening was that the copper had been torn somewhere uphill. It was about 25 feet away from the unit.
You mean insulation?
The insulation. Yeah, that's a good word.
Yeah.
Yeah, the insulation around the copper had been torn. And so we had about a foot of exposed copper in the attic. And it would condensate and then just drain down through the insulation all the way down to the unit. drip into the unit and work its way to the lowest point. And from inside the house, it looks like we have an issue with our pump. We have a cracked drain pan maybe, or we have a drain that keeps backing up. It's a frustrating problem to try to solve, but it goes back to that chase the water all the way up to the highest point. But yeah, the copper insulation is another common one that you get the customer complaints from.
Yeah. Tubing insulation, drains being insulated
Drains as
properly.
well.
That's
Yeah.
another one. That's more of a humid climate thing. A lot of climates, you don't have to worry about it. But if you're in a humid climate, you need to insulate your drain. Any horizontal portions, at least, is also a big thing to mention.
How do you solve that really common complaint where my condenser outside is draining water onto the concrete pad?
You have to put a drain pan underneath the condenser
Oh,
and then put a float switch in. That's fine. Every time it rains, it shuts the air conditioner off.
oh, shoot. Nice.
So if you're in a humid climate, it's going to sweat outside.
Yeah.
And that's just going to happen. I mean, I guess you could insulate everything, including the compressor.
We should probably address setting customer expectations because we are in a very humid climate. And so that is actually a really common freak out moment for a customer has upgraded their equipment. They have now the ability to dehumidify and their compressor is going to run a little longer and a little colder.
Mhm.
And we got water forming outside on the condenser and they freak out about it. Another scenario would be a garage unit where you have just a really high dew point. It's not unusual to have a 78-degree dew point in a garage in Florida. And the outside of that air handler is going to sweat. If it runs long enough, if they set the temperature cool enough inside, if it's in dehumidification, it's going to sweat. And so there are
Well, it wouldn't
scenarios.
have to if the gosh darn manufacturers would just insulate them a little better.
That's
I think
probably-
that's worth
that's true.
saying. You don't have to say gosh darn, but
That is true. A little more insulation would be nice for our climate.
dew points, they be a rising, actually. I did actually look at there's a lot of sketchy climate data, but over the last 25 years, dew points have been going up.
This has been a particular high dew point year for
It
us.
has been, yeah. And so you just get a lot of these issues, and setting customer expectations appropriately beforehand helps prevent some of those issues. So we'll blame Tyler for that.
Okay.
We'll make that his job. Yeah, let's do that. What I usually recommend when people complain about the condenser sweating on the outside pad, what I'll usually say is, that's normal. What the heck is wrong with you?
It's good.
And it seems to go fine. They just settle right down. I also usually will say, ma'am, you're going to need to calm down.
That's the way to start
And
this.
then they just calm right down and they feel great and there's no problem. Final thing I wanted to mention was in markets where you do have traps near the air handlers or furnaces, it is clean out, then trap, then vent. Clean out is closed, then trap, then vent. Any funny things you have to do to make a system drain? Well, I have to drill a hole in the cap, and or if it won't drain unless yeah.
Man, I used to really believe in that. I don't know when that switched, but the amount of holes I've drilled into caps.
And it's not that it won't all of a sudden magically make it drain, because sometimes it will, but there's something else happening.
Mm-hmm.
Something else is going on here that's causing that to do that. And a lot of times it's static pressure issues. It's like airflow related issues.
And about that vent, you better bring that vent up above
The drain pan.
drain pan.
Right.
And it better be sealed.
Yeah. What do you mean sealed?
If you just take a piece of PVC and you stick it into that T in the top of that vent and you don't glue it,
Oh, right.
and the drain backs
Right.
up.
When you say sealed, it sounds like you mean capped, and that's not
I
what you
meant
mean.
glued.
You mean it's actually glued. So you glue the vent in place and it's above the pan. Now,
Yeah.
if you're doing vents after traps on RTUs, you want them to be lower than the drain pan, because if it backs up, you'd rather the water come out of the T
It's good
than go
work.
back into the equipment. So something
good
to
work.
think about there. I think that's basically it. There's a lot of other things we could talk about condensation and all that, but I think that covers it pretty well. It wasn't really that much of a Spidey Sense. It was more just like situational awareness, I think.
It is.
Which is what Spidey Sense is, honestly,
It is.
I guess. Yeah.
Yeah, it is important to have that. You do have the new techs that come in and just clean a drain and walk away.
Which is like, what's the name of the karate instructor who Kip and Napoleon go to?
Rex
Kwando.
Rex
right.
Kwando.
So whereas a lot of new
Clean the
techs,
drain.
walk away. Clean the drain.
Clean the drain, walk away every time.
Okay. Hey, glad we could have this talk.
Yeah, same.
Again, big thanks to Bert. Big thanks to all of our sponsors and partners who make this podcast possible. From the very beginning, it's been many of the same folks who you hear the ads on all the podcasts. But just remember, they have partnered with me. It's not like I'm directly helping them sell product. It's sort of roundabout. And I think it's cool
brands that have that mindset, who understand that long-term investment in education and how that pays off in the long run. So I think that's cool. And anyway, I just encourage you to consider buying from those people. Also, if you want to find out more about everything that we do and learn more about our sponsors and all that, you can go to HVACrschool.com. And I suggest that you look up the Symposium. Symposium is our live event. It is right before AHR. AHR is in Orlando. That's the big event. I'm going to be there doing podcast pavilions and all that at the Orange County Convention Center. And our symposium we are planning to have at the Ocoee Lakeside Center instead of the Kalos office. So it's going to be a 2-day event instead of 3, and it's going to be there instead of the Kalos office, so we can have approximately twice the number of people that we had last time because there's so much demand around AHR. The only reason that we haven't announced the location yet is because we're still in permitting and we just have to make 100% sure that it goes through. I know some of you are like, wow, this is really, the way you guys are doing this is really cutting it close. That's how we do it every year. We are not primarily an events organization. We do this event and it's normally this small thing that we do at our shop. So it's kind of a stretch for us. I think it's still going to be great. I'm sure it will be. It'll probably be better than ever, honestly, because there'll be more of you and we'll get a chance to experience that. Just another side note, we did close on a property that we intend to be the long-term home of Kalos and a new training center. So over the next couple years, we hope to get that built out, and then that will also be the home of the symposium in the long run. So lots of future plans with all that stuff, lots of fun stuff that we're excited about, and hopefully we'll get a chance to meet you in Orlando here sometime soon. So the other day, my wife dropped the laundry basket, and I guess she's angry that I just stood there and watched it all unfold. Thanks for listening. We'll talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to HVACrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.